Welcome to our Algebra 2 midterm review. This video is being recorded for anyone who misses one or both of our review days, or if you just want to go back and revisit some of the problems that we went over in class, make sure that you understand them. Make it work for you. I anticipate that this video is going to be very long. It is 22 slides. So you probably don't need to watch the whole thing all the way through unless you've missed all of the review, in which case you probably should. But you might want to put it on double time so that the video moves a little bit faster. You can hear me sound like a chipmunk, or fast forward to the particular problems where you need that explanation and need to review it a little bit more thoroughly. Additionally, I do have some Christmas music playing. It's not very loud. I don't think it'll be an issue, but it might be. And I am also still, at the time of this recording, struggling with my ear issue and stuff. So if I am popping my ears or act like I'm a little uncomfortable, that's why. So we're just going to do the best we can. Just a heads up in case, yeah, things are kind of weird. So without further ado, let's get into this review. So the first bank of questions, we're actually going to approach this two different ways. I'm going to show you how to do it without a graphing utility and with a graphing utility. So my classes and a lot of classes are allowed and have been using Desmos to do a lot of these problems or to visualize the solutions. If you are not using Desmos, if you're watching this from, I don't know, some other school or something, then you want to make sure that you know what kind of utilities you're allowed to use and that you can utilize those. But this video is going to focus on Desmos. First question here is the point 2, -3 a solution to the equation 2x minus 4y equals 5, and how do you know? And of course, it's the how do you know piece of that is so important. It's not just can you generate yes or no, but that you understand why. And so that comes down to what is a solution. So all of these questions are basically assessing, do you understand what a solution is? When you're asked to solve something or identify a solution or pull the solution out of multiple choice, whatever it might be, how do you know what you're looking for? And the solution is the value of the variables that make the equations, system, inequality, whatever it might be, true. Okay, so to figure this one out for the first one, we have 2x minus 4y equals 5. And then we have the point 2, -3. Well, in that point, x is equal to 2 and y is equal to -3. So what I'm going to do over here is plug in x is equal to 2 and y is equal to -3, and we're going to see if that results in a true statement. So 2 times 2 is 4. -4 times -3 is positive 12. And at this point, you can probably see this is not going to be a true statement. If I do finish it out, okay, I end up with 16 equals 5, which is false. And so the answer to the question is no. Okay, is that point a solution to that equation? The answer to that is no. How do I know? Because it doesn't make the equation true. Now, that same principle works for inequalities, systems. It works for everything. That's what we're looking for when we're looking for solutions. So the next question, is x equals 4 a solution to the inequality? So we have -2x plus 3 is less than or equal to -5. And I'm going to plug in a 4. And so we get -8 plus 3 is less than or equal to 5, and I get -5 is less than or equal to -5. Now, it's important to know how inequalities work. -5 is not less than -5. A number can't be less than itself, but it can be equal to itself. And that's the piece of this that this particular value satisfies. So that is a true statement, and your answer to the question would be yes. But the reason, again, how do you know, is because it makes the inequality true. And then we have this last one, is 0, 3 in the solution set to y is less than 1/2 x minus 5. And we do that the same way as we do the other. So we have x is equal to 0 and y is equal to 3. And I'm going to go ahead and plug those values in. And I get 3 is less than 1/2 times 0 minus 5. So 3 is less than -5, which is false. And so the answer is no. Okay, again, the idea, like the critical idea behind these questions and any questions like it is, do you understand what a solution is? Okay, that's what you want to walk away from the review with. Not, can I get a yes or a no answer, but do I understand the concept? Because if you understand the concept, somebody can mess around with how they ask the question. They can ask it with a graph. They can ask it like in other ways, and you would still be able to answer the question. Now, on this slide, and this is where hopefully I can navigate the PowerPoint, okay? No, hang on. There we go. You can also answer these using Desmos. I'm going to go ahead and open the graphing calculator. And we can look at all of these. I don't think we really need to look at all of them to get the point, but on Desmos, I can type in that first equation. Okay, and then you can see it. And with Desmos, if I come over here and I click, like I can, look at the x-intercept, the y-intercept, but I can also click on it and you can see all of the different points. And of course, the question is the point 2, -3 on the line? Because that's what a graph is. A graph is the solutions. It's just a picture of all the solutions. So I'm going to go ahead and plot the point, and what you can see here is that the point 2, -3 is not on the line. Therefore, the answer to the question is no. This is not a solution because it doesn't make the equation true, and that's what a graph is. A graph is the picture of all the points that make the equation true. So you should be able to do this different ways. Now, looking at the inequality, will jump down to the fourth one there. Y is less than 1/2 x minus 5. And then you don't have to plot the point, but okay. With an inequality, you've actually got more solutions. So you could have the original function, like where the line is. In this case, the line is not included. That's why it's dashed. And then you have this whole shaded region. And then you can look up here and you find your 0.03, and it's not in the shaded region. Therefore, it is a no. And then I'm actually not totally sure how that one in the middle will work. I'm going to go ahead and take a peek at it. We want less than or equal to -5. And we were asked about the point, like the 4. And if I click right there, you can see where x is equal to 4. And just notice how the line is solid. So anywhere that's shaded would be a solution. So it would be anywhere on the line because the line is solid, or in that shaded region over here. So this is the equal to part. And then this would be the the less, but yeah, this is like probably you're like, wait a minute, why is it like shaded in the greater than direction if it's a less than? It just has to do with if you were to solve that for x. So okay, so that I hope gets us through the first 3 of those review questions in 2 different ways. So you can do this with the plugging the numbers in and looking for something true, or you can visualize it on the graph. Either way, and one way is not more correct than another. Okay, so for this one, for the function shown below, state the intervals where it's increasing, decreasing, positive, and negative. Turn to a matching or multiple choice question as needed. So the harder level of this would be you state the intervals where it is positive, negative, increasing, decreasing. On a multiple choice exam, such as your midterm is, you would just need to be able to identify those intervals. So you would have your 4 answer choices, and you would need to be able to pick the right one out of the options. Now, as long as you understand what interval you're looking for, that should make the question easier. So let's go and do this. I'm going to turn on the highlighter. And we'll do it one at a time. So increasing means going up or getting larger from left to right. And if I highlight where it's increasing, that is my interval where it's increasing right there. Now, when you are stating the interval, you do want to make sure that you're using your x coordinates, not the y coordinates. So I need to go and reference that -5. And I would say this is increasing from -5 and then going in the positive direction. So we would say to infinity. A distractor choice, if I were writing this question, and just for reference, I did write this question. So here's what you can expect. I would go and use that y coordinate, which looks like it's a -8. And I would make one of the distractor choices -8 to infinity, seeing if I could get a student to say that it was increasing from -8 upward, like see if I could trick them into using the y coordinate. So make sure that you are using the x coordinate for that. Now for decreasing, decreasing would be going down from left to right. And again, you want to make sure you're using that the x coordinate, and it's decreasing from -infinity and it stops decreasing at the -5. Okay, so you always do the smaller value to the left. So you would not say -5 to -infinity. Okay, you would not say that because -5 is bigger. -infinity is further over to the left. And again, I would also try to trick a student into using the y coordinate. So I might say infinity to -8 or something to try to get somebody to pick the wrong answer choice. So what's important here is to know what increasing and decreasing mean. Now, for this next one, I think just for fun and to make the video more like a multiple choice question is we'll do positive, okay? And I'm going to put up on the screen here what I would put maybe as some answer choices for positive, okay? So I would say, I'll do this one, like maybe that's answer choice A, answer choice B, answer choice C, and answer choice D. Okay, so if you're watching, well, obviously, if you're watching this, you're watching this. So take a moment and decide, what would you pick? Could you identify the value for where it's positive from looking at the multiple choice? So pause the video as needed and just give yourself a chance to think about that. Okay, now hopefully you didn't pick these ones because I just went over increasing and decreasing, and we've established that those are the intervals for increasing and decreasing. So you wouldn't pick those. So that leaves us with -7 to -3, or like the outside of that. So if you had the -7 to the -3, that would be this band right in here. And then the -infinity down to the -7 or -3 to positive infinity would be that band. And you do need to remember what it means for something to be positive. Positive means that it is above the y-axis, or the y value is positive. If you look closely at it, this chunk of it is where it is negative. And so it's not going to be the -7 and -3, it would be this value here, because there's actually two pieces where it is positive. All right, and then answer choice C would be the answer choice for where it is negative. So the important thing here is to understand what those vocab words mean. When we tested on this, there was considerable confusion between, say, increasing and positive. There were a lot of students that thought that those were the same thing, and decreasing and negative, but they are not the same thing. So what you want to make sure you understand is is what those words mean. And then you can, at least on this midterm, grab a highlighter. You can highlight the test and then look at the answer choices and try to match them up that way. Okay, so that is our second concept. Right, now this one is identify the family to which the following function belongs. So just looking at the table, this is not necessarily easy to do. So from a table, tables are great for a lot of things. They're great for recording data if you are making the measurements yourself. They are great for being really specific. They give you exact data, exact values. They are not particularly great for seeing specific relationships. Okay, they're just not. They're not particularly great for that. What's good for identifying families is probably an equation or a graph. And so with this one, you guys can't see. I'm like sitting here pointing at the screen like a fool here. Okay, with this one. This does not lend itself to writing the equation. Okay, maybe you could, but if you're given a bunch of points, probably what you want to do is graph them. So if you are not using a graphing calculator, you can sketch these by hand. It doesn't have to take a long time, because remember, the point of a graph is not necessarily to be super precise. It's to picture a relationship. That's what graphs do. They allow us to draw a picture of how like X and Y are related to each other. And a lot of times it doesn't have to be super precise in order to be useful. So looking at this, I have the point -2, 6, 1, 2, 3, 4, 5, 6. Okay. So there's my first point. -1, 3. And put that there. Okay. 0, 2. All right. And 1, 3. Okay. So what you're not going to pick is line, because that is not a line. And 2, 6. Okay. And again, this isn't a fancy graph and stuff. And I'm going to go ahead and connect those. So okay, now here are the ones that we've studied so far. We've studied linear, we've studied quadratic, we've studied absolute value families, and those are the only ones to this point whose graphs we've explored. So if this is a 4-question multiple choice test, there might be some distractor choice, maybe something you've never seen before, maybe a made-up word. Okay, maybe I'd put like the word curved in. Okay, see if somebody's gonna buy it. Like they slept all through class, so they don't even know that we didn't study curved. So hopefully with this, you are not picking linear. Linear has to look like a line, and that is not a line. And hopefully you also recognize that curved, or whatever the other distractor choice is, you recognize like that is not something that we've covered, so I'm not going to pick that. Now, absolute value and quadratic can be a little trickier to tell the difference between, because they both have they'll both have the same kind of symmetry. A quadratic is rounded and absolute value is not. So we often say one of them looks like a U, one looks like a V. Okay. So the question now is, with this one, is that rounded or is that V-shaped? And remember with absolute value that the two sides have to be lines. If I look closely at this, that is not a line, because it's steeper and then it gets less steep as we're getting closer to that vertex. And so steep, and then less steep means it has to be a quadratic. Meaning that basically that's going to be curved there, because if it were absolute value, it would come down in that straight line all the way down to the vertex. And this one is not, which means it can't be absolute value. So that one is a quadratic. And then the next question here, how can we tell from looking at an equation whether the function is linear, quadratic, or absolute value? Generate an example of each. So short story on that one. Absolute value better have an absolute value in it somewhere. Okay. If you don't see an absolute value, somewhere in the function that's not in that family. Lines take two main forms. One of them is your slope-intercept form, and the other is what's called standard form, which we do see. I'm making up some numbers here, okay? I don't know why I did that, but so the key thing with a line is that you would have an x and you'd have a y, and just an x and just a y. There's no absolute value, there's no squaring, there's no cubing, there's no square root stuff happening over your x. A quadratic can take one of three forms, okay? So it could look like that in standard form, or we looked at what's called vertex form, okay? Or we also looked at something called factored form. In all of those forms, the key thing about a quadratic is that you have an x squared, okay? That's your key thing. With the standard form, it's easy to see the x squared. With this one, it's a little bit harder. Just you know that the x is in the parentheses and the parentheses are being squared. So you would have x squared there. Factored form, when you multiply these, so when you go to do x minus b times x minus q, you will have a step where you multiply x times x and your x squared would come out there. Okay, so a good multiple choice question might be something like giving you 4 equations and saying which one of these is quadratic, or which one is linear, which one is absolute value. You could say which one of these is not linear, okay, which one of these is not quadratic. So those are the ways that you might be asked a question on that particular skill. Now, for this one, I did want to go in and just review how to do this on Desmos. I'm not actually totally sure what I was thinking, but so you can plot the individual points. I know in my class, like a lot of students have done that. And so if you wanted to get that much more accurate view there, so we have item 3 and what was my last one? 2, 6. Okay, and you guess, I mean, it looks all pretty colors, and you can see a little bit better in that that it is not absolute value. So where your hand-drawn one might, depending on how good you are at hand drawing it, you can definitely see here that they are not the same steepness there. Okay. You can also, and we'll actually, you know what, we'll review it in a future slide. So that's how you can plot the points there. All right, hopefully I didn't skip a slide. I don't even know how I did that. Hopefully I didn't skip a slide. Well, if I did, I did. I'm sorry. I'm also hungry. Okay, so this is a big question. We're going to park ourselves on this slide for a little bit. Find the vertex of each of the parabolas given in the tables, and then state the axis of symmetry for each. This is tied to a standard that asks you to compare the key features of quadratics, the quadratic graphs, from tables, from verbal descriptions. And so there's a little review note that says students should review the definition of maximum and minimum, know how to find the axis of symmetry given the x-intercept. Some students will want to use regression to answer these. So let's go ahead and start working this one out. So to do this, we are going to review regression in this particular problem. To do a regression curve, we are going to click the little plus sign, and we're going to choose table. All right, now I'm actually going to click all the way down. Wait a minute, I think I left out the 0. Hang on there. There we go. And then over here we have 13, 6, 1, -2, and -3. Now you might be able to get a decent picture of the graph from here, okay? So that depending on what your answer choices are, you might be able to see enough to be able to answer the question. But if you want to know like the exact like maximum, minimum, maybe the axis of symmetry, so forth, what we need to do is a regression. So for my students, this should be a review, okay? So I should be able to go through it fairly quickly. There's another whole separate video somewhere on my YouTube channel just on how to do the regressions. But to do a regression, you do need to use those subscripts, the X1 and the Y1. And then you need to use the little tilde, okay, when you're, and that tells Desmos, hey, go back and do a regression. So we will do Y1. Now it doesn't tell us what form the equation needs to take, so it honestly doesn't matter, I guess. I'm going to go ahead and use standard form. So A x1 squared plus b x1 plus c. And if you needed the formula, there it is. So that came from 1x squared minus 4x plus 1 was the equation for that. And in this particular question, it said find the vertex and then state the axis of symmetry. So the vertex is right over there. It looks like it's at 2, -3. And so I'm debating what I want to do here. Come over here. So for this one, the vertex is at 2, -3. Now, I can, if I want to save time, come over here and I can leave my regression alone. And if you notice, the x coordinates here on the parabolas are the same. So I'm just going to come over here and just edit the y coordinates. So that would be 3, 9, 19, 33, and 51. And what you'll notice is that that regression still stays in place. So this particular parabola is y equals 2x squared plus 12x plus 19. And if I click over here, I can see that the vertex on that one is the point -3, 1. Okay. So vertex is -3, 1. Right, now it says find the vertex of each of the parabolas, then state the axis of symmetry. So the axis of symmetry is the vertical line running right through the middle. It is going to go through the vertex. And so the axis of symmetry for the first one would be x equals 2. The axis of symmetry for the second one would be x is equal to -3. Don't fall for, using the y. Don't put the ordered pair and so forth. Now, over there on the review notes, this is like kind of notes that I made to myself when I was developing the review of like, okay, what other things kind of fall under this umbrella of comparing the key traits of the parabolas. So as a definition of maximum or minimum. So maximum and minimum, I think most of you know intuitively what those words mean. Specifically, though, when it comes to a parabola, the maximum or the minimum is the highest or lowest y value, okay? Because they're either going to go up forever or down forever. Maxmin, it has to do with the y value. So for this particular parabola, the minimum is 1. Okay, so we could say the minimum is y equals 1. On this one, I think like the minimum was y equals -3. Okay, so yeah, the minimum was y equals -3. And so like a question you might be asked is which one of these has the smaller minimum value, or which one has the bigger maximum value? Or you could be asked questions about the location of the axis of symmetry. Okay. And then it says, know how to find the axis of symmetry given the x-intercepts. And so if you, now this particular parabola doesn't have any x-intercepts, so that makes it not like a great example, but let's see if I can, if you had something that did, okay, have the x-intercepts and you were told, okay, you have an x-intercept here and an x-intercept here, the axis of symmetry would have to be right in between them. And so I would count like 1, 2, 3, 4, 5. So I would go halfway, which would be 2.5, which would be right about there. And that would be at x equals negative, oh, sorry, not, I don't even know, like 2.5. Yeah, I don't know what my deal is. I'm just going to blame the fact that I still don't feel well. What is that? That's 4.5. There we go. 4.5. Okay. So it would be exactly halfway between. So those are like the different skills. Make sure that you can do regression if you are one of my students and you know you're going to have access to the Desmos calculator. If you need to do a regression, do a regression. Also note that you can do regressions in different forms. So you could do this one. Okay, this would give you your regression in vertex form, or you could do your regression in factored form. Okay, so you could do it in the various forms. And hopefully that is familiar to you. So if you learned that and you did fairly well on that in the Unit 2 test earlier this quarter, then that comes back to you and you're like, okay, just make sure you hop into Desmos on your own and do a couple just to make sure that you're not hiccuping over some, what's one of the things that can happen? The table can accidentally get kicked over to X2, Y2 is something that can happen if you have multiple tables. And so you have to make sure you use the right subscript in there. Okay. So I think that reviews that particular slide and those particular skills pretty well, comparing the maximum, minimum, vertex, x-intercepts, and so forth. All right, Nellie Ne'er-do-well. People that have me for engineering will recognize that because I use Nellie Ne'er-do-well as an example of somebody who steals your work off the internet. Nellie Ne'er-do-well has trouble keeping track of her money. She has $500 in her savings account and withdraws $75 per month. If this relationship is graphed, which number is the slope and which is the y-intercept? And then an additional question there, what would the x-intercept represent? And so let's go take a look at that graph. So this would be time in months, and this would be the amount of money that Nellie has. And she starts out with the $500. Okay, so she starts out with $500. And then every month that goes by, she withdraws $75. Okay. And so that is not to scale. Okay, it's not quite that steep. I should probably try to do it a little bit more to scale. What is she's withdrawing like 75 a month? So it might look more like that. Okay, like maybe something more like that. Okay, so what we would want to know, this is one of those, can you identify what these points mean in the context of a situation? So last one was just, what's the vertex? Where's the axis of symmetry? When you're applying your math, those critical points on the graph correspond to something that has meaning for us. So in this example, it says if this relationship is graphed, which one is the slope and which is the y-intercept? I hope that everybody can look at that and say, okay, well, the 500 is the y-intercept. So the y-intercept corresponds to the amount of money that Nellie is starting with, which means by process of elimination that the $75 per month would have to be the slope. And in this case, it would actually be negative $75 because she is spending money. If she were saving money and she was putting money into her bank account, the line would be going up, okay, and she would have a positive slope on it. So those are two key things. And let's say it says, what would the x-intercept represent? So without finding it, the x-intercept is some number and then 0. Okay, and remember the y is the money. Y is the money. So, and this is a time. So the x-intercept would be the time when she runs out of money. So on a linear graph, those are pretty much the three key things. You've got the x-intercept, the y-intercept, and the slope. Y-intercept typically corresponds to some kind of starting value or base value. Slope is rate of change. Okay, so it's always like rise over run. It's got two different pieces to it. So this would be $75 per 1 month. And there's the two numbers there, and that's going to be however it's changing, or going up or going down. And then the x-intercept, if there is one, which if she were saving money, we wouldn't have an x-intercept, so would be like a time until something is 0, whatever you have on your y-axis. Okay, so there's different ways that you could see problems like this and be asked about the representation of the numbers within the context of the problem. All right, so this slide is all polynomial operations. I think I have it on different slides, so I think I did it. I can't see because I opened Desmos. So let's take a look at the first one. The first one is 3x minus 4 all squared. So a lot of you are going to be tempted to just do 3x squared and 4 squared and call it a day. Except remember that squaring means multiply by itself. And you want to look closely at what is being squared. The parentheses are being squared. Therefore, it is the parentheses that are being multiplied by themselves. You may FOIL this, just use your distribution. In my class, we have been doing the area model. And so I'm going to set that up as an area model so that I'm being consistent. 3 times 3 is 9. X times x is x squared. This is negative 12x. This is another negative 12x. And then this would be positive 16. And then you would need to add all of them up. As we love it when it happens, the like terms are on the diagonal. And so my final answer would be 9x squared. Negative 12 plus negative 12 is negative 24 plus 16. Okay, so do remember that when you're looking at squaring something in parentheses, it does mean that you actually need to multiply the whole parentheses together. You cannot just multiply or square the pieces inside the parentheses. Next one. And we're going to be using the area model for this. So this is x to the third, 4x, and a negative 1. And we're multiplying that by 2x minus 1. And pretty much all the area model is a way to picture multiplying and dividing as an area. And it's a way of organizing your distribution. So here we have 2x times x to the third, which would give us 2x to the fourth. 2x times 4x is 8x squared. 2x times negative 1 is negative 2x. Negative 1 times x to the third is negative 1x to the third. This would be negative 4x, and negative 1 times negative 1 is positive 1. And then you need to find your like terms. So we do have two like terms right there. Negative 4x plus negative 2x is negative 6x. On my other diagonal, they don't match. So you have the x to the third and the x squared. So those cannot be combined. That your answer would be the area of the whole thing. And we do try to put them in descending exponent order. And there we have it. Moving on. Look, I'm pretty sure of that. I allotted 2 slides for this, and that was so that I wouldn't have to cram my work in or erase it. So this next one is subtraction. Please note that you need to subtract there. So when I go to do this, I'm going to have 3x to the fourth plus 2x to the third minus 2x squared plus 3x plus 1. You have to subtract everything in the second set of parentheses. So I will be doing minus x to the fourth minus 6x to the third. If I am minusing a negative, that becomes adding, and the same thing right here. If I were writing the distractor choices for this, which I did not, but if I were, I would definitely have a distractor choice where only the first thing was subtracted, okay, or where there are sign errors when you're subtracting a negative and so forth. So that is like, you can, if you make that mistake, you can expect, if it's a good multiple choice test, that somebody has factored that into what they think you might do. Then just like watch your like terms. So 3x to the fourth minus x to the fourth is 2x to the fourth. 2x to the third minus 6x to the third is negative 4x to the third. Negative 2x squared plus 5x squared is 3x squared. The 3x doesn't have anything to combine with, so we just bring that down. And then 1 plus 5 is 6. Take your time, do it right. Everybody can do these problems. These are not like really difficult problems to do. So, but they are error prone. If you go too fast, you will make mistakes. Next one is a division problem. So for my classes, we are going to approach this with the area model. Whatever your highest exponent is, that's the number of columns that you need. So I'm going to set up 3 columns, and we are dividing by x minus 1. And so I'll start with that 2x to the third. And here we go. X times what gives me 2x to the third? That is 2x squared. 2x squared times negative 1 is negative 2x squared. And we need our x squareds to add up to positive 4x squared, which means that this has to be a 6x squared. X times 6x would give me the 6x squared. 6x times negative 1 is negative 6x. And for those, we need those to add up to positive 5. What was I thinking when I wrote this problem? So that means this has to be 11x, which makes this an 11 and this a negative 11. And we need a 1, and we have a negative 11, which means my remainder has to be 12 in order to get them to add up to a positive 1. And so my final answer is 2x squared plus 6x plus 11 plus 12 over my divisor, which in this case is x minus 1. Yay. Now, the polynomial operation that's not accounted for here is adding, but we do a lot of the adding inside the division, inside the multiplication, and inside the subtraction. So didn't feel like that was worth a separate like review problem. Just do note this here. Okay, so essentially we did 2 multiplications because there was special emphasis put on the squaring. means you're probably going to see that on your midterm, and you will need to know how to navigate that. Okay, next one is simplifying some square roots. So let's go ahead and do this out. There is a way to do this on Desmos. I have not taught my students how to do it on Desmos, so I'm the one making the video. Here we go. Negative 100. Okay, we know that negative 100 is equal to 100 times negative 1. And then we have a property of square roots that allows us to take the square root of each of those separately. The square root of 100 is 10. You have to drop the square root when you take it, okay? So if you write this, that is wrong, okay? That square root has to go away when you take the square root. And what happens about maybe like not half the time, but maybe it is half the time. It's a lot, is that students will end up taking the square root more than once, okay? So we don't want to do that. Now, this one is actually intended to review your imaginary numbers. The square root of negative 1 is I. Therefore, the square root of negative 100 is 10i. Next one. We have the square root of negative 18. So that can first be split up into 18 times negative 1. Now, the 18, though, I can't take the square root of it. So I need to see if I can factor that more in such a way that there is something I can take the square root of. So if you try to factor it like this, okay, I can't take the square root of 3 and I can't take the square root of 6. So that does not work. However, if I try the square root of 2 times 9, okay, that should work because I can take the square root of 9. So I'd have the square root of 2 times the square root of 9 times the square root of negative 1. Square root of 2 is stuck, but the square root of 9 is 3, and the square root of negative 1 we already established was I. And so now that's probably enough to get a multiple choice question right. Typically, though, we'll take anything that's not under the square root and we'll write the multiplication around front because multiplication is commutative. It doesn't matter what order you do it in. So that simplifies all the way to 3i root 2, which is how you would say it. The last one here is 3 root 12. And this one, remember, this is multiplication right there between the 3 and the 12. And so we're going to go through this process that we did with the blue here, except with the 12. So if you pick 6 times 2, 6 times 2, you can't take the square root of either of those, and so you don't get anywhere, but you can take the square root of 4. And so this brings us to the square root of 4 times the square root of 3. Square root of 4 is 2. The square root symbol has to go away. And then 3 times 2 is 6. Notice a couple things before we move on from this slide. Notice that I am working from top to bottom. I am still seeing what I call loosey-goosey scratch work, where it moves all over the place. If you are moving like up and down and left and right and upside down and sideways, what will happen is you leave pieces out, you forget to copy a square root over, just bad things happen. So every line following from the line above it. And let's see. Okay. I'm probably gonna get a lot more text messages now. Okay, so moving on. These are your operations with complex numbers, okay? So this is dealing with your I, and we already dealt a little bit with I. We said that I is equal to the square root of negative 1. The other way we often think of that is I squared is equal to negative 1. Now, that's the same definition, just written 2 different ways. Just one of them, basically you just square both sides or square root both sides, and you can go from one definition to the other. It just is maybe nice to have them both written out on the page. So for the first one, we have 3i times 2i minus 1. You can do this with the area model, but most of you probably wouldn't bother to because it's a super boring rectangle. Okay, you would just distribute 3 times 2 is 6. I times I is I squared minus 3i. Now, if you were dealing with x's, that would be the end of the problem. But we're not dealing with x's, we're dealing with i's. So while they look like variables, and we often treat them like variables, they are not variables. We know exactly what I is. Okay, I is equal to square root of -1. Therefore, I squared is equal to -1. And we end up with what? -6 minus 3i. Okay, yay. All right, and then the next one is just an addition problem. So this is similar to your polynomial one. You just combine like terms. So I'll go ahead and review that. 4 plus 1. So yeah, we're just combining the real parts with the other real parts, and then the imaginary parts with the other imaginary parts. So -3i plus 2i is -1i. And then, you know, it doesn't really matter if you have the 1 there or not. So if you were like looking at your multiple choice answers, hopefully you would recognize that 5 minus I was the same thing. Now, common mistakes that students make with the i's, I get I times I equals I all the time. I don't know why. It's not. I times I is I squared, and then I squared equals -1. I also get a lot of I is equal to -1, which is not true because we already have a -1. We don't need another one. It's I squared is -1, and those details matter. So if you're tempted to just write that off as, like I'll get it close enough, they matter. And because as math teachers, we see certain mistakes all the time. When we're writing a multiple choice test, we know exactly what people are prone to do, and those are the other choices because we want our multiple choice test to really pull out like what we know, what we don't know. Now, combined with the polynomial operations, we have reviewed adding, subtracting, multiplying, and dividing. So we grab the adding over here, but keep in mind that the other things that we saw for the polynomial operations might also be true for the I. So for example, subtracting. So you might have subtracting your complex numbers, you might have squaring a complex number, and so forth. Okay. So those skills need to transfer in between the two types problems. Solve the following system. Now, my classes did systems exclusively by graphing. It's not a separate Algebra 2 standard. Okay, so we don't have to do a whole thing on systems. You should have done them in Algebra 1. I have a feeling we have a bit of a content gap there, but they're not something separate that needs to be done in Algebra 2. So we approached it in my class as a graphing problem, and that is how we are going to approach it now. So with the graphing calculator, the way we do this. Now, I'm going to go back and kind of briefly talk about the vocab here because it matters. The solving, if we go all the way back to that very first slide, solving means finding the values of the variables that make something true. And so when you're solving a system, you're looking for the values of the variables that make both of them true, because that definition is going to keep carrying through. Like we don't change what it is we're looking for when we're solving. The other thing is that the graph is the picture of the points that make the equation true. So when I type into Desmos that first equation, what I'm getting is a picture of all of the points that make that particular equation true, whether they're happy points, like, I don't even know if we got a happy point, like -1, -5, or 0, -4, or whether they're ugly points like 1.53 and 1.401. Like when I plug them in, they'll make them true. And then I'll come down here and I'll plug in the second equation. And now I've got a picture of the points that make all of that equation true. But this is a system. And a system is the points that make both equations true, which would necessarily have to be where they intersect. So in this particular example, they would be the points 2, 4 and -2, -4, and then you would need to pick those off of your multiple choice. Now, what I have found some students do is they find every place there's a dot and they're like, oh, look at all those dots. That must be a solution. Desmos is an amazingly powerful tool, but it doesn't know what you're trying to do. And so it's going to put dots any place it thinks might be a point of interest for you. You, the doer of the math, need to know which of those points you are looking for. So this particular system has 2 solutions, and there they are. Okay, probably the fastest, most accurate way for you guys to get the solutions to those systems. There are some algebraic ways, and I know some of the other Algebra 2 teachers have done this algebraically. You just have to make sure if you're watching this video to review for someone else's class that you know what is going to be expected of you in that class. All right, given the parent function, y equals the absolute value of x, write the equation of the function that is reflected over the x-axis, has a vertical stretch of a factor of 3, and shifts left 4 units. There is no work for you to show for this. I will put up kind of our template here, okay, and review quickly what these mean. A negative there is going to flip it over the x-axis. This is a stretch or a compress, and how you know the difference is if it is greater than 1, it's a stretch. If it's less than 1, you're compressing it. The h value, if you have a positive, like if it says plus, it's going to go left. If you have a minus, it's going to go right. And your k value, a plus means it's going up and a minus means it is going down. So if I am starting with the parent function, y equals the absolute value of x, and I want to reflect it over the x-axis, then I know that will be a negative. If I want to stretch it by a factor of 3, that means I'll be multiplying it by a 3. And if I want it to go left 4 units, I will add 4 inside the absolute value. There is no vertical, like up-down translation on there. And so there's no plus or minus outside the absolute value. If you wanted to write like plus 0, that would be fine. Okay. This is just material that you need to know. Now, it's been a long time since we've done this, which is why we review for your midterm so that you can see it again. But the better you learned it a couple months ago, it comes back to you pretty quickly. Now, the next one says, given f of x is equal to x plus 2 all squared minus 3, write the function g of x such that g of x is equal to f of x plus 4 minus 3. So I'm going to erase this kind of little cheat sheet over here. If you're taking some notes, you need to write it down, pause the video and do that. All right. I don't know how the video is recording, but I'm getting a very weird delay already. So if I look at this, I know from what I just wrote that this has to go left 4 and down 3. So there's several different ways you can do this. So one way you could do it is, I'm going to write up here, is you could say this is already left 2 and down 3. So if you want it to go left 4, you would add 4 more, which means you would now be going left 6. And then it's already down 3. So if you wanted to go down 3 more, that would put you down 6. That's probably how I would do it. You could also do it more algebraically. You could also graph it. Okay, so Desmos is available to you guys on your midterm. So you could go and graph the original function right here and then see what that's going to do. And part of this is understanding that notation, that the +4 on the inside means that it's going to go left 4, and then the -3 on the outside means it's going to go down 3. So lots of different ways you could do that. Also remember, when you're doing a multiple choice test, that you might be able to play process of elimination with some of your answer choices. Okay, so if you know you're supposed to be subtracting 3, you wouldn't pick something that said, +3. Okay. So make sure you use some common sense there as well. So those are your transformation questions. I have no idea. I feel like we must be getting near the end. Write the equation for the parabola going through this. Now, there are different ways to do this, but the way I am going to review it in this PowerPoint is by doing that regression. That is the best way to do it. So clicking that plus sign, going to the table, and plugging in the points. So we have -4 and 2, and this was 5, 5, and 1. All right, so we want the equation for that. Now, at this point, you should look at your answer choices and see what form the answer choices are in. So if the answer choices are in, say, vertex form, you want to have your answer choice in, you want to make sure you do a vertex form regression, which would look something not like that, like this. Okay, and so you can see in vertex form, not that I can see it, hang on. It's like not showing. Oh, well, wait, plus K. There we go. There we go. That's better. A is equal to 1, H is equal to -2, and K is equal to 1. Okay, so you would pick that answer choice. If it were in standard form, you would have Y1. All right, so at some point on the left side, I know it froze, and I know what that means, so hopefully we don't lose like too much time. So next question. A random unidentified projectile has a trajectory modeled by h of t equals -0.5 times x minus 3 all squared plus 6. What is the object's highest height, starting height, and when does it land? So this is going back to that same benchmark where you have to associate like the key points on the graph with what they would represent in real life. Now, this one, you can, if you look at the form of the equation here, oh, sorry, there we go. The form of the equation is in vertex form. So you're able to get the vertex fairly easily here. It goes right 3 and up 6. And so the vertex would be at the point 3, 6. It's got a negative out front, which means it is upside down. And you could probably figure out the object's highest height is a 6. The rest of these questions are not good for the form that you have it in. So your best bet, if you have access to a graphing utility, is to go ahead and graph it. Now keep in mind that Desmos will not recognize the H and the T. And then I obviously made a boo-boo when I did that. I swapped the T out for an X. When you enter it in, you need to, I think that it might be okay with the H. No, I don't think it's okay with the H. You can use f of x or you can use a y. So we have negative, and this is x minus 3 all squared plus 6. And this is what I was just referring to, like the form that's given in, you're able to get the 3, 6. So, but you've got these like key points here, and you do want to know what those key points mean. So I'm going to go ahead and turn on the pen. Okay. If this is a projectile is just something that's thrown, launched, or dropped. Okay. I think this definition has to do with whether or not it's the only force acting on it is whatever force like got it in motion, and then gravity. So, if you were asked the object's highest height, okay, that would be the 6. So that is the highest height. And then the starting height would be right here, okay, 1.5. I guess I don't even think we have units on this, but that would be your starting height, because that would be time is equal to 0. When does it hit the highest height? Well, that's a slightly different question. When does it hit the highest height would be the 3. When does it get to the max height? So you've got the maximum height is 6, and when does it get to the 6? It gets to the 6 when the time is 3. When does it land? Well, that's going to be over here. Okay, this would be a when, sometimes where it lands. It depends on how your variables are defined. But the easiest way to answer a question like that is to graph the parabola and then actually identify what those key points are. So, and there's not a whole lot else you can be asked on that. You know, when it hits the highest point, what is the highest point? If for some reason it's you know, a U shape, it could be something like a bridge that's sagging or something like that. Like, what is the minimum? When does it get to the minimum? When does it land? That's going to be literally like when it looks like it's hitting the x-intercept, because the height is 0, and then so forth. Now, you can find those things algebraically. You can get them off of the equation. You could figure out when it lands by making h 0 and then solving it for x using your equation solving skills for quadratics. You could figure out the starting height by plugging in x is equal to 0 at the beginning, or t equals 0. But if you have access to a graphing utility, the quickest, surest way of answering all of the different questions that you might be asked is to take a look at the graph. Oh, okay. Hang on, getting very tired of recording this video. It's very long. All right, next bank of questions. Factor each of the following. So there's a lot of different factoring things that you can cover. These 4 problems give you pretty much all of them. So the first one is 2x squared minus 32. And the first thing we want to remember about factoring anything is to look for a GCF, okay? And so in 2x squared minus 32, what you should realize is that they have a common factor of 2. And so we undistribute that. And then this particular problem is going after the review of the difference of squares. Remember that difference means subtraction, and when the things you are subtracting are perfect squares, you have this kind of what's called a special case of the difference of squares. And the difference of squares always factors into what are called conjugates. And so we would have the square root of each. So x plus 4 and x minus 4. And then in conjugates, the middle signs are opposite, which is what causes the middle term to drop out when you multiply them together. So you can expect to see a difference of squares. Most of the time when you're assessing factoring, you need to kind of hit all the key things. And so this particular practice problem gets that GCF and also gets at the difference of squares. The next problem down, x squared plus 11x plus 28, this is a trinomial with a leading coefficient of 1. So this is one of the easier versions, and we will do this using the area model just to be consistent with how we approached it in class. So we set this up. We know that we're going to have x squared in the upper left, and we're going to have 28 in the lower right. And then we're looking for 2 linear terms that are going to add up to that 11x. But when you multiply them, they're going to give you that 28. And if you followed us through the polynomial division, I think it gets a little bit easier to come back and do this with the factoring because you've seen it work with the polynomial division, which is a little bit more complicated. But we're going to factor that 28. Okay, so that factors into 1 times 28, 2 times 14, not 3 times anything, 4 times 7, not 5, not 6. Okay, we're good. And then the one of those that adds up to the 11 is the 4 and the 7. And for ones where the leading coefficient is 1, it's not too bad because the only way for you to get x squared in that upper left-hand box is to do x times x. When you have a leading coefficient, you have to look more closely at your GCFs moving across or up or down. 7 times x is what gives us 7x. 4 times x is what gives us 4x. And so the factors, the things that were multiplied to give us that area were x plus 4 and x plus 7. Alrighty, moving on to the next slide. So I did the same thing I did on the other one. I basically gave myself 2 slides so that I didn't have to cram stuff in. So this third one is another factoring, but this time the leading coefficient is not 1. You have a 3. And that makes everything so much more fun. So now we still need to find something that adds up to 11, but you're not going to find anything that adds up to 11 and also multiplies to give you 20. That's not a thing. So in order to get the right numbers in there, what we need to do is take the 3 and multiply it by the 20, and we get 60. And now we have to explore factors of 60. Now 60 is an awful number to work with, but we go through it. So 1 times 60, 2 times 30. We're just on the lookout for something that will add up to give us an 11. 3 times 20, 4 times 15. I like 4 times 15. If I do -4 and +15, that should work. I'm not going to jump on it too quickly though. We have 5 times 12, 6 times 10, not 7, not 8, not 9. Okay. And that just is making sure that we've caught all of them. Nothing here works for the 11 except the 4 and the 15. Now, I will say when you're writing a test and you really want to assess students' factoring skills, you try to write the problems to avoid like the going backwards. So like if you are doing multiple choice, you could just multiply the answer choices together and see which one gives you the original expression, but we can find ways with GCFs and stuff to give you multiple options that are going to do that. So just heads up. So let's see, this is, we'll do the negative 4x here and the 15x here. And now you do need to be careful with the 3x. So you need to know, is it 3x here and x here, or is it 3x up here and x here? And the way you can figure that out is to look for greatest common factor. So if you look right across here for the greatest common factor, the 3 and the 4 don't have a common factor, but they do share a factor of x. And if you look this way, they have a common factor of x, but 3 and 15 also share a common factor of 3x. And from here, usually students don't have a problem with it. So x times negative 4 will give you the negative 4x. 3x times 5 would give you the 15x. And then you can check your factoring by checking that lower right. 5 times negative 4 would give you the negative 20. So the factors are x plus 5 and 3x minus 4. Ta-da. All right. Last but not least is the 4x plus 4. And again, you want to make sure that you are looking for a GCF. Now, this is a little bit tricky here. Like if I rewrote this, this is going to seem like a weird step, but 4 is equal to 4 times 1. Okay, so that seems like a really weird thing to do. Why would you do that? Well, because when I go to factor out the 4, I'm left with a 1. Sometimes if you just circle the 4, students are like, oh, there's nothing left there. Now, you want to look to see if you can factor that further, but x plus 1 actually doesn't factor any further. And so the point of this review problem is to just remind you that sometimes the GCF is all there is. Sometimes there is only a GCF and you would factor GCF and you would be done. Okay, so you can expect several factoring questions on your midterm that are going to cover the breadth of the different types of factoring that we looked at, and also are going to try to mitigate the working the problem backwards kind of deal. All right, this is a quadratic inequality, and I need to turn off my pen. So these are actually pretty awful to do by hand. If you were going to do one of these, it's not letting me turn off my pen. Turn. No. Okay. There we go. So yeah, these are pretty awful to do by hand. You actually have to like factor and then get what are called like test points to see which test points are going to make that inequality true. Again, going back to the definition of solve all the way from the beginning of this video, like a million hours ago. But solving is you're looking for the values that will make it true. So you can play a couple of games with a multiple choice test where you could look at your answer choices and pick values of x in each of the intervals and then work from there. But it's not bad to do out if you have access to Desmos, which you do, at least my students do. Okay. So we go ahead and we put that in Desmos, and then we know Desmos is shading the solutions. And so if I look closely at the solutions here, they go from -5 over here to +1. Okay, now from that, you can probably get a pretty good guess at what the answer choice will be, or like what to pick. However, a well-written multiple choice test is going to try to trip you up on some of the notation. So this one would be -5 is less than x is less than 1, but somebody might give you this. Okay, now just for the record, that's the one that you're picking. Okay, -5 is less than x is less than 1. But somebody might give you with the or like equal to sign. If it doesn't match what was in the original problem, though, don't pick it. Somebody might do this. They might do like x is less than -5, x is greater than 1, which would be these intervals out here. They might mess up the, I'm just trying to think of like what I would do, might do something like this, okay, where they give you the right numbers, but like they're messed up in how the inequalities are turned around. So they should always be facing the same direction, and it's usually going to be the like less than. Okay, you're usually going to read them as less than because we go from left to right, like least to greater. So use some common sense with that. Don't pick stuff that's got the inequalities oriented in a strange way, or that messes with the kind of inequality that you have. If you were to see this with interval notation, it would be this -5 to 1, okay, would be the answer in interval notation. And I can only speak for this year, but you do see both. You see interval notation and inequality notation on there. Okay, so there's your quadratic inequality. And I think this is almost to the very end. So there are several different solving the quadratics, and there are different strategies for solving quadratics. So when I wrote the review for this, I tried to hit the different ways that you can solve quadratics. So the way this review is written, this one you are supposed to solve by factoring. This one is with the quadratic formula, and this one is quadratic formula or by a square root. My classes solve this with the square root, but I think I am the only teacher that covered that. Maybe not that covered like solving it that particular way. And so if you're watching this from another class, another teacher, and you're like, what do you mean solving it with square roots? Don't do it that way. You need to do it the way your teacher taught you how to do it. So we'll start with the factoring, and then we'll see how far that goes. So with the factoring, you do need to make sure that you have a 0 on one side, because when we solve a quadratic by factoring, we engage the 0 product property. And so to engage that, I do need to make sure that I subtract 23x from both sides and the 6 from both sides to get 4x squared minus 23x minus 6 is equal to 0. And now we are told to do this by factoring. So let's go ahead and do our scratch work. So we have 4x squared, we have -6, and then because we have that leading coefficient, we need to make sure we do 4 times 6, we get 24. And we're going to factor that 24. We're looking for factors that add up to -23. I always, every time I do this in class, when I've done it in a video, I always start with 1 times the number, because that's the combination that people tend to forget, and it is the combination that works in this particular case. Others are 2 times 12, 3 times 8, and 4 times 6. But we are looking for something that adds up to 23, which will necessarily be, or -23. So it would have to be a positive 1x and a negative 24x. So don't forget, like 1 times the number. It's a thing. Okay, looking for that GCF, the only thing that 4x squared and 1x have in common is the x. And then once we get there, we're pretty much okay to go. So x times 4x gives you 4x squared, x times 1 gives you the 1x. This would be a -6, and then we can check -6 times 1, which would give us the -6. So the factors are x minus 6 and 4x plus 1. And then we engage the zero product property, so x minus 6 could be equal to 0, or 4x plus 1 is equal to 0. And we just solve each of those independently. So adding 6 to both sides, we get x could be equal to 6. And then honestly, what I would do at that point is, since you know, that's awful, bugs me when it's really bad. Okay, there we go. What I would do is go look at your answer choices, and since you know x equals 6 is one of the answers, go and eliminate any of the answer choices that don't have x equals 6. You might get lucky and you're able to eliminate all but one, and then you don't have to do the rest of the problem. So you play those tests smart. So this one, though, we would subtract the 1 and then divide by 4. And so x is equal to negative 1/4. And you do need to have both of the answers. You can also graph this and check the answers when you're graphing, so don't forget that that's a strategy as well. Now, in the interest of space, I'm going to jump over and do the square rooting one, okay? Because I don't think that's quite enough space for the quadratic formula, and I know I have the next full slide. So this one, for my students, I would want you to square root it. I would want you to recognize that when you don't have an x term, or when the b value is 0, that you can use square rooting. And so to use square rooting, we would subtract the 50 from both sides. And we get 2x squared equals negative 50. And then let's go ahead and divide by 2. And I get x squared is equal to negative 25. Now, hopefully at that moment, you realize, hold up, whenever you square a number, you get something positive or 0 if x is equal to 0. This is true unless you are dealing with an imaginary number, which we've covered, and so they're fair game. So when I go to take the square root, okay, then we end up with the square root of negative 25. Which of course we've already reviewed this earlier in this PowerPoint. So that's 25 times negative 1. And we get the square root of 25 is 5. The square root of negative 1 is I. And so we get 5i. Now here's where we want to be like just super like alert. If I have, say, x squared is equal to, we'll use a totally different number. We'll say x squared is equal to 49. There are actually 2 answers to that. You could have 7, because 7 times 7 is equal to 49, or you could also have negative 7, because negative 7 times negative 7 would also give you positive 49. The same is true when you're dealing with the square roots of negatives, that you could have the positive or the negative, so you'd want to make sure that you got both of the answers. Probably the most efficient way to do that particular problem. However, if you have not been taught how to do it that way, I would not recommend trying to learn a new way for the midterm. You want to make sure that on your midterm you are sticking with things that have been well explained to you and that you're more comfortable doing, which means for that problem, you would probably want to use the quadratic formula. So let's go from over here and review the quadratic formula. It is the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. You are given the quadratic formula on your reference sheet. Make sure you identify a, b, and c correctly. I have graded most of the in-class tests for Unit 3, but a lot of them had x's in there with the a, b, and c. A, B, and C are only numbers. They are only ever numbers. You will never, ever, ever see an X floating around inside with those A's, B's, and C's in the quadratic formula, okay? No, never. Now, once you identify A, B, and C, then it's just a matter of plugging them in. So we have X is equal to the opposite of B. Well, if B is positive 4, then the opposite of positive 4 is negative 4. I have been super clear in my classes. Put that in parentheses. because it sometimes causes a mistake, over 2 times A. And then use Desmos for everything it is worth, or use your handheld calculator if you are not using Desmos. Okay, so don't like try to do this in your head. It's just rife with all kinds of mistakes. Okay, so we have -4 plus or minus, this will be 16 minus 8. Okay, and for your midterm, you are going to be expected to simplify this. So there's several things you can do. You can put this into Desmos and get the decimal, and then try to match the decimals with the answer choices. Okay, that works. You can actually go back and graph it and see, what the x-intercepts are, and then try to match those decimals with the answer choices. There's a lot of ways you can try to get around doing this. The way that you are intended to do it is, I'm doing a little scratch work up here, is you're supposed to simplify the square root of 8. Okay, and that's square root of 4 is 2. Okay, that's scratch work, just so you know what that is. So this becomes x is equal to -4 plus or minus 2 root 2 over 4. And then this is where there's like different ways you can handle this. This is still not simplified the whole way. I think what I am going to do for the purposes of this video is I am going to factor the -4 into 2 times 2. And this is 2 times the square root of 2, and then your denominator is 2 times 2. And what you can do is cancel out one of those 2's, but you have to cancel it out like everywhere. You can't just cancel it out in like one place. So you can't cancel out the 2's with like the 2 4's. Like you can't cancel the 2 4's out and then leave the other piece of it alone. And that gets into understanding what factors are and how fractions work, which I know is a weak spot, but also not necessarily something that we can cover right now. So we have -2 plus or minus, and now that's just a root 2 over 2. And that's the answer choice that you would be looking at. Now, a couple of things before we leave quadratic formula. Make sure that you don't make foolish mistakes. So you're given the formula. I wish I had a nickel for every time somebody was given the formula and then still plug the numbers into the wrong place. So I would see a lot of like C values here, like, and it's not, and it's 2A. So yeah, that would be 2 times 2. But on the test, like I saw a lot of 2 times C. Make sure that you're copying the whole formula over and you're not moving things around. So a lot of you drop the plus or minus, you change the minus sign to a plus sign, like things like that fall under the umbrella of carelessness. It's a kind of nasty formula that has a lot of parts to it, but it is navigable if you attend to it. Don't rely, like I did that in my head, but I wrote this problem, and also I do a lot of these. Use the tools that you have. And the other thing that I see a lot of is the scratch work. Like notice when I do the scratch work, I take it off to the side. I don't put the scratch work right inside the problem, because sometimes what happens is you do the scratch work and you drop the other pieces to it, and then those other pieces never come back. Notice the fraction bar doesn't keep getting shorter, like the length of that fraction bar does matter. So all of those like little things, if you get lazy about them, they will cause you to end up with the wrong answer for a problem that basically you know how to do. And I always tell my students, if you're going to get something wrong, make sure it's something that you legitimately have no clue about, not something that you do know how to do or you could get right, but you're getting it wrong because you're not bothering to tighten up on the pieces of it. Okay. Again, there's other ways you can get answers to this that are not cheating. Says we don't cheat. We are not math weighing our way through our midterm. In fact, that'll be a real quick way to land yourself with a 0 on your midterm. That is not recoverable. So don't do that. But you can hop into Desmos. You can look at the solutions on Desmos and then run through the A, B, C, D answer choices and see if you can match the answer choice decimal to the decimal that you see on Desmos. That's not cheating. It gets you around using the quadratic formula, but it's using like valid tools that you have available, and it's using your knowledge of what a graph looks like and how to use those tools to get around it. It's not, you're not looking the answer up anywhere. Right, last slide. Oh my word, didn't think we'd get here. What is the error in the solution below? And so you will see a problem on your midterm that involves looking at a proposed solution and then seeing what's wrong in it. Please do not answer there is no error. I'm not sure that that's an answer choice option. I don't have the final or midterm in front of me, but I mean, if it says what is the error, we're not trying to be mean and like, oh, let's see if we can trick them into looking for something that's not there. Now, there are tests that do that. There are professors and teachers that will do that. Like it might say, like, is there an error? And if so, what it is. So like then, but if it just says, what is the error? So looking at this, this is a subtraction problem. So you got two ways you can navigate your way through something like this. You can work the problem out on your own to the side or on your scratch paper and then see when your work is different from the work and then see like, okay, what makes my work different? Or you can just look over that and kind of trace it through with your eyes. Like that's whatever you think you're going to do better with. So remember when you're subtracting that subtraction goes with the whole expression. So this will be minus 5x squared minus 2x and then minus a negative, which would give us a plus. And then immediately we notice that that does not match what is written in the proposed solution. If we want to focus on, okay, what's different? This all the way up to here is all the same. Right here is where we see it different. And then we see it different right here. And then we would need to look at what is that mistake. You kind of have to look at the answer choices and say which of the answer choices describes the mistake that I'm seeing there. In this case, you could say something like the negative was not distributed or the subtraction was not distributed. The person did not subtract all of the second polynomial. Lots of different ways it could be phrased. I will say this for this particular review, for this particular midterm, this particular year, that there's not more than one error. So once you have identified the error, you don't need to look at the next steps to see if there's something else that's wrong. Okay. So once you find the mistake, you're good to go. You can answer that question. All right. I know this video was super long. It had some glitches in it. I know that it froze on one spot. Hopefully it was just that one spot. It seems like it's working okay now. And I don't really expect anybody to watch this entire video all the way through unless you completely missed all of the review, in which case this is absolutely your best way to figure out what do I need to know and get some practice for the midterm. Otherwise, do what you need to do with it. And my students at least know how to reach me if they have any questions. All right.